Hello, my name is Ashley Barker, and this is my attempt to answer the question, how much would it cost to power the United States completely using solar? Before I get into the math, I wanted to state my underlying assumptions. For this estimation, I assumed that the power generation would be commercial, even though in reality it would likely be a combination of residential and commercial, because I am assuming that the majority of consumption and therefore generation will need to be commercial. I used values given for 2018 in order to be consistent, and to simplify the math, I used the commercial price of PV because it was the solar source I was able to find the most information for. And then the final assumption I made was that the US would want to store roughly half of the energy generated in order to have energy usage during the nighttime. The first thing I needed to know was the total energy usage of the United States, which Professor Krensky gave to us as 101.25 quadrillion BTUs in 2018. This value is equal to 29,673 terawatt hours, which I then multiplied by the number of hours in a year, which is about 8,760, in order to get an average rate of energy consumption of 3.39 terawatts. Given this information, I needed to know what percentage of the potential solar energy could be used compared to the electrical energy usage using the net capacity factor, which is used to compare different types of electricity production. From the U.S. Energy Information Administration, the capacity factor for solar is on average about 28%, which means that mathematically I would need to divide the 3.39 terawatts of electric by 0.28 in order to quantify the equivalent amount of usable solar energy, which resulted in about 12 terawatts of solar energy. According to the National Renewable Energy Laboratory, the cost of commercial PV in 2018 was $1.83 per watt. By multiplying the cost per watt by 12 terawatts, the final total generation cost is $22 trillion. For the storage, I found that the cost of lithium-ion battery is about $380 per megawatt hour for 4-hour storage systems from the Energy Efficiency and Renewable Energy page on energy.gov. I then multiplied this price by the annual nighttime hours, which is about 4,380, and then also multiplied by half of the average rate of energy consumption of 6 terawatts, which resulted in a storage cost of $10 trillion. Therefore, the final cost estimation for generation and storage of half of the generated energy is the $22 trillion in generation costs, in addition to the $10 trillion storage cost, which results in a total cost of $32 trillion. This estimation is what it would cost to power the U.S. completely using solar-generated energy. This estimation does not include any research or development costs, nor the cost of the initial installation of PV. Thank you.